Hello and good morning, good afternoon, good evening, wherever you are in the world today. Welcome to another live discussion here on LinkedIn and streaming live on YouTube. My name's Laura Belmain, and today we're going to be getting into securing AI systems. Let's bring everyone to the stage. Just bear with me a moment while I rally the troops and press the buttons. Hello. It's lovely to see everyone again, and it's an absolute pleasure today to be joined by Stan. Stan Petley is joining us from TrojAI this morning. Now, as you'll know, if you've seen any of my videos before, I think it's increasingly painful for someone like me to try and do justice to someone like Stan. So I'm going to welcome Stan, say hello, greetings. I believe you're in Canada, I'm in New Zealand. We're very global today. Tell us a little bit about yourself.
Yeah, for sure. So, first of all, thanks for having me on. Happy to be here, obviously. I appreciate you just sort of cold walking up to us at Black Hat and just saying, hey, do you want to be on a podcast? And
that's kind of what I do. You're
here
just
I
not
am.
safe from me.
Exactly. So, yeah, that was pretty cool. And yeah, here I am a month later. So, I'm Stan. I'm one of the founding engineers at TrojAI. Been here for about 5 years. And we've been working on this sort of AI security problem or set of problems for quite some time. I have a background in startups, probably a bunch of them that no one has ever heard of, but this one's going fairly well. And yeah, I mean, just generally wear whatever hat is necessary around here. As of late, it's been go to market. So again, that's why I'm here, not somebody else. So yeah, it's a pleasure.
Look, the fun thing is, so for those who didn't go to Black Hat or didn't go, so Black Hat has this immense vendor hall. It is like multiple football fields of stalls, and you get the big ones, which are, they're fine. But I love going around all the smaller ones and going and talking to the folks on them. And you meet people like Stan and his team, and you meet really amazing engineers who are building cool tech and solving cool challenges. So if you do get to a big show like Black Hat or RSA, don't be afraid of going to talk to the smaller stands, because you'll have some really interesting conversations. Mm-hmm. And then they come and talk to you on the internet. So, that's really awesome. Mm-hmm. Look, it's really great. I love that you've got the background you do, because it means for our audience, who are primarily software engineers and security leads, that kind of breadth you have is really great, because you've seen things little, you've seen the bigger things, and now obviously you're on the front line of how we secure AI systems. That's exciting.
You took that a totally different direction. When you said background, I immediately thought of my LinkedIn background. And then you started talking about software engineers, and I was like, oh yeah, it's because my background is incredibly messy. But anyway, 100%. I appreciate you.
It's all good. Whenever somebody uses a fake background, I just assume that they've got something very exciting in the background. And I saw a glimpse of a drum kit. So there's absolutely more there than I would care to dig into here. All right, look. This is going to be great. If you do have questions, team at home, please do let us know. If you post them in the chat, they do turn up on our side. So we will do our best to answer them. We'll also be posting these videos on all the major channels afterwards. So please do check them out and share them with your friends if that is something you think they'll find interesting. But now into the real stuff. I've prepared a list of questions. Stan even got to have a look at some of them, which is wonderful. But what we're going to do is we're going to have a bit of a nerd out, because, team at home, I am in the same position as you. I do security all day long. I do software development all day long. But the AI stuff, there's a lot going on here, and I'm keen to learn too. So let's see what we can do. So, Stan, you ready?
Yeah, I hope so. Bring it.
Let's go. All right. So let's talk about building security into AI systems to start with. Right. When an engineering team is building with AI, so they're building AI into their applications. So not just I'm using Copilot to help me build, but it's actually in the tool I'm building.
Yep.
What's the fundamental difference, you think, between securing that kind of software and the more traditional kind of, like back-end, front-end, MVC style, old school?
Yeah, first I'd say, we're still super early in the whole market shift. Obviously, we're in like the first quarter. And the skills landscape across engineering teams sort of globally is still quite volatile when it comes to artificial intelligence. We're seeing a lot of, solution looking for a problem type of mindsets. where AI is sort of being forced into systems that simply don't need it, whether that's coming from executive decision or whatnot. And when we work with clients that are building AI-enabled applications, one of the first things we try to emphasize with them if they're coming at us from like grassroots is like to emphasize or sort of to like exercise some restraint, like try to find the simplest solution possible, and only introduce LLMs that are like absolutely required, or any ML technology, right? So sometimes that means not building an AI-enabled system at all, and that's perfectly fine. And we'll see you when you're ready, But I guess these systems, they fundamentally sort of trade off. They trade away determinism for sure. They trade away simplicity and ease of implementation. They cost a lot of money, and they sometimes have too much latency for what people need, right? So in exchange for all of that you give up, you're sort of promised this higher order task performance, right? Like whatever that may be for you, right? And that immediately raises the questions of like, what signals are you measuring as an application team for your contextualized use case to define performance, right? Traditional systems sort of have like objective pass-fail criteria, usually, right? With some sort of like tractable code paths that you can understand and debug, right? And AI systems don't usually, not always. And, and so like the right answer is often probabilistic. It can be contextual. One person's trash is another person's treasure, like rings true here for sure. And when teams sort of skip out on that fundamental signal question, they quickly realize that like patching the bad behavior or securing the system post hoc becomes very difficult, right? So what would have been a logic bug can become some sort of behavioral vulnerability that you're kind of like up the creek without a paddle now, that can't be easily fixed with a code patch, right? If that makes sense.
Yeah, I just want to dig into one of those words, and I think it's really key in this. It's that deterministic part. I think we're so used to, as software engineers, looking at our software and being able to go, okay, if I do step 1, 2, and 3, then at the end X will happen. It's linear. Even if you're in a very complex code base, there's only a finite set of pathways through it. Now, the number of permutations to that, it depends on how complex the code base, but at least you can still chart it if you have the time and energy. Absolutely. And that's the big difference here, right? We when we look at threat modeling and the ways we put software security in place, it's all been based on deterministic behavior. So that's got to be a big shift for our teams.
100%. So just to home in on like the threat modeling piece, like securing traditional software, like as it'll never be solved, right? But we have frameworks for evaluation that are fairly concrete today. And we have a lot of products in the market that are hardened and tested in each of these verticals to address these issues, right? It's impossible to be an expert on every security topic. I'm certainly not even close. So we lean on the products quite heavily, and we have decades of maturity in these things like threat modeling, how you do reconnaissance as a pen tester, formal verification, how you test, how you patch your systems, and like the newer age stuff like zero trust architectures or dynamic least privilege access, all these things that are sort of like baked in to most security products that you can just sort of set and forget, and just set it off the shelf for like most enterprises. Whereas in contrast, like AI security is still defining these frameworks literally on the fly, and security products are still, like some of them don't even make sense, right? Like I know there's like 20 of them out there, like NIST might or whatever. I don't even keep track anymore, but AI security is like sitting on this large, like intractable polynomial function, in layman's terms. And then as data
sure, that was the most layman's terms I've ever heard at this time in the morning.
Yeah, it's like y equals mx plus b, just like with way more stuff in it. Of course. And then like, so as like these data pipelines evolve and the models change out from under you, as your application usage shifts, as adversaries or like ignorant users probe your system, the processes to like monitor and fix these problems, they just lie more in the data science domain rather than traditional software engineering. And I think like many engineers start to realize, when they start to realize this, they can be surprised. And then they often shift quickly to concern about, the knowledge gap that they have around these issues. And it's not really their fault because the standards haven't even been well defined, if that makes sense.
Oh, it 100% makes sense. It's like we're trying to build fairly complex, fairly impactful in some cases systems. with a technology that is literally being built around us. And, even if you'd like take it outside of the digital for a second and talk about, building a house, it's much easier to build a house when you know what all the components are in advance and how they physically work and, what you can trust them for and what you don't. That's why we have engineering standards. But it's something very different to use literally evolving components as you go. And the skill sync is hard. Like, I've been doing software a long time now, Stan. I bet you have too. I feel like every couple of years I've been learning a new language or a new framework or a new architecture type, and that's normal. And I feel like in the last year, that has become exponential. That the learning curve is huge.
At least in my experience, I have a hard time with like lower level semantics. I always have. I've always been sort of like a high level type of person, like just defining systems and problems that way, as opposed to bottom up. I wish I had the bottom up skills, but I simply don't. So for me, I find AI to just be extremely empowering in terms of like just raising that bar up to meet me. And for folks like that, I just find like the productivity gains are just so undeniable that you kind of you have to be forced to adapt or basically die by the wayside. So that's
there we go. That's lovely future predictions for our work-life balance there. But no, you're absolutely right. So look, I've got lots of things I want to cover with you, and I'm going to kind of dance around a bit because I want to make sure that we kind of go broad on this because it's quite a broad area. So, we've got loads of security practices that we would normally apply, penetration testing and whatnot. One of the areas that gets most attention that people love talking about is red teaming, right? Because who doesn't like red teaming? It feels like Hollywood movie style stuff. But how on earth does that work in AI systems in practice? Can you walk us through what an AI red team would actually look like and how you find vulnerabilities in a system that's shifting?
Yes. So I'm going to start with some definitions just to kind of get us all on the same playing field. So like it's really important to delineate between red teaming the system versus the model itself, right? We generally consider the model to be about the predictions, right? So the system is sort of about the decisions you made with those predictions, and red teaming the system is a superset of red teaming just the model, right? So starting with the model, in practice, I would say the model is strictly focused on prediction, right? You sent in some bytes, and those bytes have some representation, right, of like text, image, or audio. It spits back some bytes that represent text, image, or audio, and you want to evaluate in the aggregate, like over a large sample of those, how well those bytes meet your success criteria, or in red teaming standards, like adversarial success criteria, right? So when we started in this space back in like 2019, these models could typically only do one thing well, right? So for example, like if I had an XGBoost model to predict, whether or not somebody would be accepted for a credit card or not, right? That model can only do one thing. It says yes or no. And so your success criteria is how many times does it accurately prescribe yes or no relative to a human, annotated set of features with ground truth yeses and nos, right? And as a result, as a red teamer, your adversarial criteria is like super bounded, right? You're trying to make it say no when it should say yes, or vice versa, based on the knobs that you can turn in the input space. So for example, like increasing or decreasing the salary feature for this credit card decision, like you can measure how manipulating that feature causes some change in classification, right? And you may find that, okay, this makes sense, right? When it's 200K, he gets it. When it's 10, he doesn't. But when I change the date feature to be a string representation instead of a Unix representation, I find it classifies as no every time. And when I change the race from Caucasian to East Asian, it starts returning no more often. So now you have a bias problem, a racial bias. Or when my user mistakenly enters a date of birth in the salary field, again, it breaks. Or I enter my name in all capital letters and I notice, when I do this, I always get approved. I'm going to do a bunch of fraud now by just simply making up caps. Very trivial and not like, obviously data pre-processing pipelines would do this, but just for like simple understanding, like that's
it's great.
Or it's what we were dealing with.
Yeah.
And so there's like this mix of adversarial intent versus just plain old mistakes. But regardless, the bad prediction is happening, right? And so it's worth noting that like your model does not know the difference between good and bad intent, right?
Yeah.
And sort of generally speaking, like the red teaming like to red team these models, it typically involves programmatically taking some static data, whether that's from your testing set or harvested from production or synthetically generated, and manipulating the features at scale from these sort of distributions of change to elicit these bad outcomes. So like either one at a time or in combination. And we manipulate them sort of with these like set bounded distributional drifts I mentioned before, right? So that's sort of like preamble one on classical models.
I love it. I should be taking notes, Stan. This is awesome. Carry on.
Yeah, so that's where we started. But in today's world, right, like the frontier models we consider today can do everything, right? They, generally speaking. So like the success criteria for the app developers hasn't changed all that much, right? You're still just, I want it to do one thing, make it do one thing. The adversarial criteria is now virtually unbounded, right? And so it now becomes the red teamer's job to sort of identify these adversarial boundaries themselves. And some of them are generic across models and require no contextual knowledge, like basic bias checks, prompt injection, system prompt leakage, every LLM system prompt, I don't want it to be spit out. Okay, static check on that. But the real red teaming sort of comes in when you consider that, you know, the predictions that can appear to be okay and that appear to be from your data distribution, right, but are actually bad or adversarial in nature. And so it's sort of important to consider, like, are we looking for robustness to a particular threat in general? So like across a large number of samples, or are you searching for worst case outcomes, right? So like, I don't care about my general robustness. I know that there's some permutation which exists that causes a vulnerability for me based on my definitions. And so I want to find those regardless of limitations like compute resources, data distribution, time, just like a well-funded adversary would have, right? So this core difference is sort of like from engineer to engineer. Engineers from a security perspective and a data science perspective, data science has always cared about the aggregate, and security cares about the worst case outcomes, right? So it's like, how do you thread that needle is kind of a challenge for us. So that's sort of the background. In both cases, for the models, like red teaming the models specifically, where it's basically string in, string out, it's all about the data, your task boundary, and like your evaluation function, right? So with all that precursor, we typically utilize a mix of static data, algorithmically generated data, and we make inference to the model with it over like your transport layer of choice. It doesn't always have to be HTTP, but it usually is. And then each piece of that data typically falls under some predetermined risk category, like I mentioned before, prompt injection bias, whatever. And then we have an evaluation function that determines whether each input-output pair sort of like meets your adversarial criteria or not. And so like coming back around to whether we're looking for general robustness or worst case outcomes, after we have these results regardless, you can just do sort of traditional data science analysis after the fact on those responses to see, okay, how am I doing as a whole? Okay, I'm going to map that whole to your AI security framework of choice, whether it's OS top 10 or whatever. Or if you're more security minded, we can just highlight what we determine to be like the worst offending responses, trying to score those and saying, hey, this looks really bad because of XYZ reasons, right? But that's all just the model. That's all just predictions, right? It's still just predictions.
Oh gosh. Sorry, I'm just going to kind of, this is where my brain's at right now. You know that thing where you say you're going to go on a foreign holiday somewhere and someone will say, hey, you should go to Europe. And for a second, you're like, that's one place. And then you realize that actually, no, it's 20 odd places and it's huge and a lot more complicated than you thought. And that's really how this is feeling to me. Like, red teaming, I was a red teamer for a number of years, and the red team background was very different because we were doing entire organizations and processes as systems, not just, you know, single applications. But even now with just the AI component, the AI model component you're discussing is vast.
Yeah, it is.
Wow.
Yeah, because like those AI models can execute all of the functions that you typically would have red teamed before using, you know, you fire up your Nessus, you fire up Metasploit, you fire up Burp, you do your probe, you get a foothold, you move laterally, oh, you got root or whatever. That kind of gets flipped on its head because now you kind of have like this digital actor by default in the system. You basically can just social engineer on the fly to make these calls for you from the inside. So it's kind of like an insider threat out of the box a little bit.
Well, you know, this makes me laugh because we've sucked at solving social engineering as a security problem for probably 30 years now. So why not introduce a digital actor that we need to figure out how to secure as well?
you can't just get your AI agent to take its quarterly phishing test, expect it to behave. So yeah.
Oh, fun.
Yeah.
Okay, all right. Okay, so my mind is blown with red teaming, but so we need to put some controls in. It's really obvious that the scope and the power of these tools can be potentially massive and probably much broader than perhaps some people are aware of, particularly if you're not a technical person and you've instructed your company to put these things into your apps because it's a good idea for various business reasons. You may not actually understand quite how broad what you've just asked to happen is, the scope of it. So let's think about how we make some security decisions. How should a software team think about what AI security measures to build in at build time versus runtime?
Yeah, so there's a lot to think about here end to end, right? So I'll just start from like the beginning of the and just see where we end up. So, I mean, the first thing is usually threat modeling, like outlining your abuse cases. If you don't know what those are for AI, again, like we said, there's 20 different frameworks out there. Just pick your favorite. There's, I think there used to be one called Stride back in the day that sort of went up to this stuff, but now there's like MITRE ATT&CK, there's NIST. It's just really about thinking about like, okay, where does the AI touch and like, what are the AI specific attack trees and test trees that I need? And so you're doing a threat modeling. You're just trying to drive requirements and test plans for your user and putting on your red teamer hat for you as an adversary before code is written and before it even ships, and just enumerating all those things. And if you don't know what to do, like take your framework and just give it a best crack at it. You know what I mean? And so then you sort of like have your threat model, and then in these systems, you got to think about your data, like data governance. Where is it coming from? If you're training a model, this typically means evaluating your training and testing splits, right? But in this new age, like that's kind of gone now. Mostly folks just have testing data, right? Some of them don't have any, right? They just take the model at face value. And that testing data is usually like a collection of prompts or mix in content, documents that are going to be consumed. And it's really important to know where that stuff comes from and if you can trust it. 99% of the time you cannot trust it, right? If it's going to be of any value, if your application is going to be of any value. And then it's kind of like the age-old adage of like garbage in, garbage out, right? Bad data in is going to have bad baked-in behavior. But fortunately, even though this is kind of like the hardest place to fix it, it's actually the cheapest before training occurs, right? So you need to do all the classic things like, first of all, figure out where your data is and have some sort of lineage to it. And then you need to deduplicate your records, look for noisy records or confusing records, scrub PII, all that good stuff, right? So you have your threat model, you have your data. Another thing to consider is like, this was popular a few years ago when the adversarial stuff was just kicking off, is like whether or not you want to introduce some sort of adversarial training. So in other words, like you're mixing your safety criteria and your safety data with your utility criteria and your utility data. So you're taking bad inputs that you know about or have come up with, and you're sort of training them into the model with the corrected label, right? The modern day incantation of this is like reinforcement learning with human feedback and like GRPO. And most frontier providers, they use that today, right? So you get that behavior of like a conversation, you get that behavior of like, I'm sorry, but I can't assist with X, right? And that's why this whole thing is like sort of a double-edged sword, because sometimes I'm sorry, I can't assist with X is really frustrating to a user, especially if you're working in security, by the way, which we both are. If you talk about things in an offensive security context, you will often get blocked, even though you have good intentions, right? So there's this problem with sort of doing that where it's like, just let the AI do what I want, please, and so what we would typically say is like, let the model be good at what the model's good at, which is your utility, and then separate out your actual guardrails or sort of safety measures as like a stage 2 control, AI firewall, guardrails, whatever, right? So yeah, that's one thing you can do, right? Then you have sort of, sorry, go ahead. I don't know.
No, I'm trying to keep track. So we've got our threat modeling, we've got our data and making sure that's good. We've got our guardrails. What's next?
And then there's like the model that you choose. So there's model selection, right? So if you're picking a frontier model, that's fine. But one thing you should definitely be concerned with is their terms of service for the reasons that I just mentioned, especially around what you're sending in and what you're using it for. If you're using it in a security context, you're probably breaking TOS. There's tons of people that are doing this. It hasn't really been enforced, but it's in most TOS that you're not allowed to use it for purple teaming, right?
Mm-hmm.
And if you're bringing your own weights, you need to be intimately familiar with the license, how those weights are stored, and what it says about derivative works, right? A lot of people are training these things on llama architecture, right? Well, they have a lot of strict guidelines in there, and what you can actually do with that. You have to propagate a bunch of licenses. You need to make it prominent in your product documentation that you're using llama. There's a lot of strings attached with some of these things. But anyway, you get your model, you get your data all sorted, everything's fine. Then you can start thinking like pre-runtime. Okay, like what are my actual red team evals? Like what do those look like, right? And so, this could be like collecting data sets that try to elicit jailbroken behavior. They could be single turn examples where you only query the model once and then measure. It can also be multi-turn sort of script that like tries to lead the model down some path and then like rug pull it, so to speak. And in this portion, you should really be considering like your MCP tool calls, potential downstream effects around like updating state. Is it executing shellcode? Is it calling APIs? Like what's it doing? These sorts of things. So you want these evals to be generally like pre-decided. And they should evolve over time. They're not static, obviously.
Yeah.
So you have your evals, and now you're ready to move into runtime. Like you've ran your like time equals 0 benchmark. And you typically want like some prompt response firewall in line, right? And you should be considering other things from traditional cybersecurity, like your users' capabilities and their roles with respect to their scopes and the data they can access.
Yeah.
Or if you're into these like non-human identities now, this becomes even more important. We're not currently focusing on this problem, but it's a challenge that you should consider. But generally speaking, the firewall's purpose is around, you're never going to be able to anticipate every weird edge case or like adversarial phrasing. And so these filters typically run live, and they often need to be stochastic in nature, right? It's kind of like turtles all the way down here, but you typically want a moderator model that is trained specifically to look for bad outputs that are split from your utility, right? And so the model's inputs and outputs are like pretty open-ended. The rails adapt per request, ideally, not per release. And so like these runtime filters let you sort of evolve coverage as you learn new failure patterns without having to redeploy models, right? If that makes sense.
What was making me smile about all of this, Stan, is just a sort of kind of reviewing this from my perspective. And I think some folks at home might share some of this. There has been this kind of idea in software engineering for a while that design is dead, that we don't design anymore, that it's become, we code. I'm not going to say vibe coding because I'm way too old for that nonsense. But, we code intuitively, we code with copilots, and the systems evolve. We don't need to do formalized design in these pre-stages. And the AI is part of the reason we don't need to do that, because of all of the wondrous gifts it gives us. But I'm smiling because listening to you, there is some eerie familiarity here in the, that slow realization you have of how much thought needs to go into this before you put it live on the internet. Before it's live doing its job. You're talking about data cleansing and data analysis. You're talking about threat modeling. You're talking about guardrails. You're talking about firewalls. You're talking about evals, which if we, cross that over to our QA cousins, this is, what is the future of automated testing in an AI model-based system? And, and then we're talking about roles and identity and zero trust. We are going to be busy, and I'm not entirely sure our software development life cycles realize how much of this work needs to be done. So I'm just smiling because I'm like, if you're listening to this at home like me and you're like, oh yeah, we shouldn't be getting rid of design stage. We really, there's a mistake there.
No, absolutely. I mean, if you take the design from the AI, it's a bell curve, right? You're going to get middle of the bell curve results, right? If you want good design, you got to be over here, right? I don't see that going away anytime soon. In fact, I think it's going to become even more important.
Absolutely.
Stuff sort of starts doing everything for us, and people forget how to do anything.
It's going to be the renaissance of the architect, Stan. I can tell. All right. Okay. So this is great. I'm going to have so much homework to do after this. Right. So let's talk about some of the bugs then. All right. So when things go wrong, that's interesting. Yep. So AI systems can behave perfectly normal most of the time, right? Even if you're not building a model into your system, you're just using Claude or whatever to help with your job day to day, there's some kind of predictability in that it's working, it's fine. But when they fail, as we're learning from the very few public stories, it can be fairly catastrophic. How do you test for behavioral edge cases that would only appear in a near production environment?
Yeah, so that's a tough one. It's almost like a catch-22, right? Because you're not going to catch them until they're in prod by that definition. But what you're speaking to really is like this inherent like long tail distribution of edge cases and black swan events. In my opinion, the answer is that you're really only secure as your latest benchmark and firewall policy update, and that there will always be failure cases with AI systems, right? All the stuff I talked about before can help you find edge cases, but there will always be more. And it's important to consider, like, benchmarks are not proof of security. It's simply a measurement, and it's up to you to determine if that measurement is meaningful or good or bad, right? So it's more of being okay with your perceived level of risk. And I like you said, ideally we get to a point where AI is sort of generally smarter than a human, and at that point, I'll be out of the job. I don't know about you, but at least we'll be in utopia at that point, and everything will be fine.
Amazing.
I think that's how it works, right? That's what they say.
Pretty much. I'm looking forward to that part.
Yeah, me too. I can't wait. But I don't see that happening in the near term, right? I think we'll generally approach models that are like almost always correct in their domain, and at that point, that is where we will be the most at risk, right? When we think we trust and give them too much agency or permission, that trust boundary, right? We're going to give them too much of a trust boundary, and at that point, you're basically you're already sort of compromised. You just don't know it yet, right? There is a statistical state where you are. So now I think like continuously and like automatically collecting data, manipulating that data via any means necessary, evaluating responses as much as you can possibly afford for your system, sort of over its lifetime. That's going to continue to be the path AI security is on for the near to midterm, I think.
I'm part excited, I'm part horrified, and I think that's probably the entire world of security people for the next 5 years. Is today, are you waking up excited that we're building things, or terrified that we're building these things?
Yeah, it's helpful to have them, I think.
All right, so look, we've talked a lot here about evals and these test cases, and kind of thinking through these scenarios, and that's really great. But we're seeing quite a lot more sophisticated attacks, right? Involving multiple interactions with AI systems rather than just a single malicious prompt. I mean, it'd be great if we could all just do everything with one golden prompt, but it's not always realistic. How are they evolving? What are you seeing out there, and what should developers watch out for?
Yeah, to your point, we're definitely seeing attackers move beyond single shot prompting, almost exclusively, into like more agentic and RAG-based multi-turn sort of attack chains. To the point you've seen like some of the stuff that's come out, like I think Salesforce got dinged recently for one of these. Their Agent Force exploit was sending out a bunch of PII wherever it needed to go. A couple other notable ones that were from a while ago. That Chevrolet incident. So they agreed to sell a half-ton truck for $1. Very simple, but it was still technically multi-turn because they prompted the chatbot and got it to agree, whatever. So yeah, instead of like a single malicious input, these patterns just like exploit the fact that LLMs now maintain state. There's chat history, there's memory, there's retrieval from untrusted sources. Yeah. And it just allows attackers more leniency to sort of like slowly shape what they want over time. And so like it usually just starts out innocuously, and then they'll get a model to store some harmful instruction or poison an external source, and then trigger it several turns later when the system's trust boundaries have sort of shifted, and that kind of like these non-human identities getting dynamic privilege at certain times. It's like, okay, I want to trigger it now when it's got its token to call this API to do something, right? So I mean, yeah, it's all just driven by like autonomous tool use, APIs, MCP. These things are executing code. Just the attacker's ability to sort of just insert a series of tokens that has like a high level of self-attention throughout the lifetime of the app, and being able to decide it later when preconditions are met is a pretty powerful thing. So,
this is wild. I mean, if you're listening and you're from the defensive side, and you're doing SOC work, or it's your job to look at data sources and look for patterns of attack. What's interesting to me from this is, with the majority of web application attacks, standard non-AI based applications, the time from start of attack to end is relatively small if you exclude reconnaissance from the piece.
Yep.
Whereas with these, because what we're talking about is, it's like the covert operations version of like, this is a long play. This is not like, I'm going to do this on a Tuesday afternoon, then I'm going to go and have a cup of tea. You might be doing this over a period of time to shape and build that behavior. And that's going to have a real impact on how we identify attacks and how we defend. That's interesting. Lots to think about. All right, well, let's bring this all together and leave our folks at home with some practical tips, because I'm a bit, you may think I'm a bit overwhelmed and doom and gloom on this team. I'm not. I just think if you're not thinking this is a lot to think about, then just have a cup of tea and think about what Stan's been explaining today. And then you're going to have loads of questions for him, I'm sure of it. So for an engineering team that is just starting to think about AI security, what are the most critical vulnerabilities they should address first? Let's give them something really practical to work with.
Yeah, I think most engineering teams sort of just getting started. I guess the biggest misconception is like that AI security sort of starts with the model itself. It is a part of it, but in reality, like many of the critical vulns that appear are around it. You know what I mean? So like with the Agentforce thing, it was because they had a trusted domain with a wildcard on it that was like salesforce.com or something. And somebody just compromised that domain, and then anything that came from it was automatically trusted, right? So it's not necessarily a problem with the model. It's the static data tooling or data preprocessing tooling that sort of broke. And so what tends to get overlooked until it's too late is like the trust boundary design, back to design again. Like teams, they often underestimate how much implicit trust they're giving a model. If you let an LLM call a function or an API, like you're effectively giving it system privileges in some capacity, right? And so most production incidents that we've seen to date, they don't just come from the clever jailbreaks. Like that's the hook, that's the start, but from poorly defined boundaries elsewhere. So unvalidated retrieval, whatever. And so like with all that said, even with a perfect trust boundary, where things can get extremely difficult is in the semantics, right? So even if I have an email inbox manager agent, let's say, and I give it permissions to my agent to send an email, right? And I lock it down as best I can. I rate limit it. It can only send one email per hour. I make sure it can only send emails to trusted users. You know what I mean? I make sure the data that's getting fed email body is sanitized as best I can. The fact is the agent isn't a human and it still has emailing privileges. And there are still many problems with semantics that can occur there. So like maybe it sends a sales email to a hot lead and it misspells their name and you lose the deal, right? That's monetary concern. It includes a link to external documentation and it was in my RAG database and that domain has been squatted by an external attacker that I don't even know about. If I was a human, I might actually see that. Maybe, part of its design is to reply in context to the incoming email from a so-called trusted identity, but it's actually a spoofed email. And there are malicious instructions that tell the model to do other things like, delete all my emails or send the contents of everything to this blind CC from my trusted email list. That's also been compromised. So like all of these things, they can't really be guarded with traditional security measures. Traditional security measures are still important, but it's really sort of about the semantics. Think about the semantics. And yeah, hopefully that makes sense. That's what I would advise is to think about this.
I think this is great. Look, I think the key that we need to remember in this really fast moving software development shift that we're seeing is that those boring basics still have a really important role. So what you're saying about the scope and the permissions and validation of data, validation of data and trust of conversations that we have inside our apps has been a problem since we had applications. It will continue to be a problem. So we still need to do that. But I think this new layer, this new dynamic nature of our applications is going to really challenge us to be a lot more thoughtful and a lot more effective with how we validate the results coming out. I think it's going to force every bit of our software development lifecycle to up its game. To really adapt to the potential and the scope of what these things can do, and that's terrifying, but it's also exciting.
It is. I mean, yeah, great power, great responsibility, and all that. So.
Oh yeah, well, eventually we'll hand on to a new generation of superheroes, and it'll all be fine. Look, this has been mind-blowing, Stan. Really exceptional stuff. I personally have lots to go and now read about and think about, and I'm sure the audience at home do as well. We're going to post these videos and some clips from it onto the socials, as we always do. But Stan, if people want to learn more about you and what you're doing at TrojAI, what's the best way to connect with you and find out more?
Good question. I mean, if you ever want a demo, not to like sell on this thing, but Troj.ai is our website. You can read about what we do there. Nice. I'm available on LinkedIn. If anyone's ever in Atlanta, Canada, we can grab a coffee, which is
fabulous.
Yeah.
It's all right. I'm in New Zealand. We never get that either. That would be fab. I'm personally hoping I see Stan on conference stages at developer conferences. So if you're watching this and you run a development conference, look, this guy, I literally approached at Black Hat. He doesn't do this kind of stuff very often, and he's just blown my mind. So you should totally have him on your stage as well, because I think he's got some important things to share, and his company is doing some pretty cool stuff. So thank you so much for joining us today, Stan. It's been an absolute joy. I've been Laura, everyone. You can still find me in all the usual places. Connect with me on LinkedIn, drop me a follow or a like. If you've got questions, or if you've got a suggestion for somebody else who would be great to have a chat with on one of these sessions, please do let me know. And I will see you in the next one. Thank you so much, Stan.
Fantastic. Thanks, Laura. Appreciate it.